And so VLANs allow us to logically group our users or our devices regardless of the location, so we don't have to be in the same location necessarily to be in the same group. Each VLAN that's configured on a switch is a separate broadcast domain. And generally we say that every VLAN should belong to its own subnet or have its own subnet. However, if I want to get from one VLAN to another, if I want to cross that VLAN, let's say I have VLAN 10, and I'm going to call that my sales VLAN, so I've grouped all my sales people together. And my sales guy wants to send a document to my engineering guy, or vice versa, and he's in VLAN 50, and I call that my engineering VLAN. Natively, if I have those two VLANs connected on the same switch, and I just want to transfer that file or that packet, that's not going to work. I can't cross that VLAN, the boundary between 10 and 50, hence broadcast domain, right? Because routers don't forward broadcast. That's one easy way to remember it. If I want that file or that packet to still get from VLAN 10 to VLAN 50, I need to route between them. And that's what this section is about, the inter VLAN routing and routing between VLANs. There are multiple ways to do it. We can configure a router that routes, and we can use one interface per VLAN on the router. And I've got a picture of this in a second, the idea. We can use a router with one trunk interface and sub-interfaces, what we refer to as router on a switch, or we can use a multi-layer switch. And we can do one of two things. We can actually configure routed ports on the multi-layer switch, or we can configure switch virtual interfaces. So if we look at the first couple, external router options, we had listed two, the router with one interface per VLAN. And if you look at it, here's the picture here. You can see I just logically made a picture of, hey, here's one interface. Let's call him FA0/0, FA0/1, FA0/2. I have to, in order to service these three VLANs, I've got to have one interface off of the router, one for each VLAN. There's no need, the advantages, I guess, if you don't have a multi-layer switch, you don't have to go buy one. But obviously, some of the big drawbacks are the router itself is a single point of failure, and it's definitely not scalable. If you have, even 5 VLANs, this becomes, kind of out of hand. And that is a lot of processing for the router. The other option is what we call router on a stick, where I can combine those VLANs and send them all across the trunk. So this way, it's an enhancement upon our previous, what we just discussed, in that I'm only using one interface, and I'm going to configure that interface as a trunk link with sub-interfaces, one sub-interface per VLAN. The great, I guess the good thing or the advantage is that I don't have to buy a multi-layer switch again. If I've already got a router and a layer 2 switch, and now suddenly I want to route this traffic, I can connect my router up, I can connect the trunk, I can configure it, and the great thing is this will work, or this connects to any switch that'll do trunking. So as long as my switch can do trunking and can have VLANs configured on, I connect my router up and I can configure it. Again, though, we've got a single point of failure, and our other big concern would be the link congestion. So we've got one link, let's say even if it's a gigabit link, may become congested depending upon the number of VLANs you try to send across it or how much VLAN traffic you try to send across it. But we're going to go ahead and we're going to configure router on a stick. We're not going to configure the external router, with one interface per VLAN, but I'm going to do we'll do a router on a stick configuration. So here's the topology I'm going to work with. I'm going to have two PCs, one in VLAN 10, one in VLAN 20. And then I've created VLAN 50 to be my native VLAN because I'm going to use 802.1q trunking across the link between the router and the switch. And if you remember with 802.1 trunking, we have what's called the native VLAN concept, which basically says any traffic that's not tagged, with some sort of a VLAN tag will go across the native VLAN. So our native VLAN is going to become, or is going to be VLAN 50. So we'll go ahead and configure that. I'm just going to pull over my console connections for my devices. The first thing I'm going to do is the PCs are already configured. The IP addresses for the PCs are 192, so in the VLAN 10, it's 192.168.10.10. And over in, oh, better go back. All right, so again, my VLAN or my IP address that I've already configured on my PC is 192.168.10.10, and on PC2, it's 192.168.20.10. And what's going to happen, what I want to be able to demonstrate is that I can ping, or in essence send packets or whatever, from PC2 to PC1 and vice versa, even though they're in different VLANs. And the way I'm going to do that is I'm going to configure this router to have sub-interfaces here, so multiple basically virtual interfaces, or interfaces configured in software. So what will happen is the traffic that needs to come from this PC is going to go up through its sub-interface that we configure. And I'm going to actually make him .20 because you don't have to, and I'll explain that in a second. But for me, it helps me understand, okay, that sub-interface is servicing VLAN 20. And then it's going to come back down through to get over to VLAN 10 or to get to PC. And then, of course, the ping reply then will come back up through this sub-interface and then go down through the other one. So we'll go ahead and configure that. I'm going to get rid of my ink here. All right, so first I'm going to go ahead and I've configured the layer 2 switch in our topology. I'm going to configure with both the two VLANs and add the host to the VLANs. Config T, VLAN 10, 20. So I've created the VLANs. Now, interestingly enough, first thing is VLANs won't actually create until I hit exit. So if right now I do a show VLAN brief, you can see those VLANs aren't there. As soon as I hit exit, I could do show, I should probably type it out if I'm going to keep doing that here. Do show VLAN brief now, and we see them. Right? The other thing you can do is when you create the interface, or at least in this iOS, when you add the interface to the VLAN, it will create the VLAN for you. So anyway, first I created the VLANs. Now I've got to add FA01 to VLAN 10, so I make sure that PC1 is in VLAN 10. Fast Ethernet or FA0/1, switch port, access VLAN 10, right? And we'll do, we got to go into VLAN 12 to put PC2 in VLAN 20. Access VLAN 20. By default, they should be shut down, but I do a lot of playing. So just in case, I'm going to do a no shut. And I'm going to do it into FA01, and we'll go back and do a no shut. So now that's fine and dandy at this point. The PCs both belong to the proper interfaces. Now what I've got to do is that connection, so if we pull this back out of our way here for a minute, this connection here has to be a trunk on both sides. So I'm going to configure this interface to be a trunk, and in particular I'm going to configure it to be a .1Q trunk. So let's pull our stuff back in here. Int FA0/2, because that's going to be my trunk. Switch port mode trunk. Now the only option for encapsulation on this particular switch is .1Q. If you had the option to do .1Q and ISL, then you would need to first configure the encapsulation type and then configure the port as a trunk. And I'm going to do a no shut. As I said earlier, I want to make my native VLAN VLAN 50, which I just realized I didn't create. So I'll just go ahead and do switch port, trunk, native. I can't remember if I needed. Oh yeah, VLAN 50. There we go. Switch port, trunk, native, VLAN 50. I should probably get my cursor out of the way. Now I'm going to go ahead and I'm going to exit out. And I'm going to make sure I configure VLAN 50. So if I do a show VLAN brief, and I can go ahead and I can see all my VLANs are created. Now if I do a show interface trunk, I don't have any yet. It is configured on this side, but it's not configured on the other side. So let's go ahead and we'll configure the router. And the interface in the router is a gigabit 00. So I'm going to configure the first sub interface. And it doesn't really matter what I do as far as this number right here is my sub portion. I like to have it follow the VLAN just so that I understand, okay, this sub interface is servicing VLAN 10. Encapsulation .1q. And then we do need the VLAN. And that number is important. So encapsulation .1q 10. And then I've got to apply an IP address to it. 192.168.10.1. Remember, my PC is 10.10. And then we'll go ahead and create, our one for VLAN 20. Encapsulation .1q VLAN 20. IP address 192.168.20.1 and our subnet mask. Alright, so I configured my sub interfaces for my VLAN 10 and 20. Now I got to configure my sub interface for VLAN 50. Gigabit 0/0.50. Encapsulation .1q 50. To this point, it's the same as what we had done for VLANs 10 and 20. Now the only difference here is that I need to specify that VLAN 50 is my native VLAN. Whoop. Forgot the 1 in there. There we go. And we got to give it an IP address. IP address 192.168.50.1. Default subnet mask, 24 bits. Now we still have one more thing left to do, and that is to activate the physical interface. Because right now we've just got all these, I don't know if you call them interfaces in software, but no ones and zeros or no electrical pulses can actually go over these configured interfaces. So I've got to issue a no shutdown command on the physical interface. And we should see, oh, there we go. So that came up. And so let's show show IP route. We should see all our connected routes. Let's see, 50, 20, and 10. So we look pretty good there, right? Now let's go over to our switch and look at our trunk. And you can see the interface came up on this side. So now that we're trunking on both sides, we should show in trunk or show interfaces trunk. We should be able to see now that we are trunking. So fast Ethernet 2 support. We are trunking. The encapsulation is 802.1q and the native VLAN is 50. So we should be good to go at this point. If I move this aside, and we'll look at our picture again. All right, so now what's going to happen is we're going to test our configuration to see that in fact we have a trunk here, and our router is going to be able to route the packets from 20 to 10. Effectively, what should happen, or what not effectively, what will happen, assuming we configured everything correctly, and I remembered to activate all the interfaces properly. I'm going to ping from PC1 to PC20. So the ping should go up through RAR1, subinterface .10, come back down through or be routed back down through .20 and come back to PC2. Okay. Here, right here, we don't need a routing protocol because all of these interfaces are seen as directly connected. So it'll be able to take that ping through one directly connected interface and route it back out the other directly connected interface. Now, if I had something else off of this router that I needed to get to, so if I had, so if I, let's say I don't know, I have another router, it's my WAN connection, so I've got another router off of here. If I need to get to this location, then I'm going to need to do routing, because instead of going, kind of in partially, in a sense, and using the directly connected interfaces and coming back out, if I need to get to here, the packet then has to go through the router, which then would require routing to get to whatever this network would be here. So we'll go ahead and erase that. But basically, I'm just saying you don't need to do routing for this simplistic topology that we have here. We'll get rid of those lines for now. And then let's go ahead and I'll pull in my console for my PC1 and PC2 and show you the IP addresses, and then I'll ping from one to the other, and it should work, and we'll move on to the next section. All right, so I already did it up above, but let's do it again. IP config to see that the IP address on PC1 is in fact 10.10. Its default gateway is 10.1. Remember, whenever you want to get off of a subnet, that's when you use the default gateway. So in order for this, when I go ahead and ping to 20.10, which is, I'll go ahead and bring that over, which is PC2's address. And we go ahead and bring this, we've got this over, we'll do an IP config again. And we can see the PC2's address is 20.10, so we're doing good. When we go to ping from this 10.10 or from this computer over to 20.10, it's got to use its default gateway. So it's going to get routed up through that subinterface at 10.1 to get off of its subnet, and then go to 20.1, and then 20.1 obviously will forward it to 20.10 out to the switch to 20.10. So let's go ahead and ping 192.168.20.10, which is the other PC, and we have connectivity. So we've correctly configured it. We're doing pretty well now. Let's just and I think that's it for this section. We've pinged, we've made sure it worked, we configured our subinterfaces, clarified that we didn't have to have routing in this instance, but if we were going to add something, we would. So next, let's look at using a multi-layer switch for routing. It's a little bit faster, gives us some more options. That would be, part of the main reason we do it. So now let's look at the first of our two options, or we can actually combine these options, but the first of the two options that we discussed earlier regarding how to do inter VLAN routing. So here we looked at switch virtual interfaces. Switch virtual interfaces are basically VLAN interfaces that have IP addresses on them and then are routed. Okay, so some of the requirements for that then are, on my multi-layer switch, the VLAN needs to be configured. A layer 2 interface needs to be up for that particular VLAN. So if in this little picture I have here, I want to route VLANs 10 and 30 using switched virtual interfaces or SVIs. So I have to have a layer 2 interface that's up for that. VLANs 10 and 30 need to be in the VLAN database, and the VLAN interface itself needs to be administratively up, meaning we've got to do a no shutdown on the VLAN interface itself. So let's go ahead and look at how to configure SVIs. Let's look at the topology that we've created. All right, so here's the topology I'm going to be working with for the SVI. Yeah, you notice in my earlier picture I just had two PCs off. It was just a simple, okay, we can have some VLANs off here, we can route between them. Here what I'm going to do is I'm going to take, I guess, what I would consider general practice. I have this large network, and I take all of these access layer switches or these layer 2 switches, and maybe those are all my hosts and my devices are off of, or the multitude of my devices. And my users are going to be off these layer 2 switches. And likely I'm going to have redundancy, so I'm going to have multiple multi-layer switches. Maybe we would call this our access and our distribution layer. Obviously I made this a lot smaller, but if you can envision having these being redundant, having these being redundant to service a whole bunch of users. And then what's going to happen is we take our access layer and we need to send that traffic then up to the core, right? Or up to the distribution and then up to the core. So if I say, okay, let's get a pen here first. I can have multiple access layer switches, you know, with different users off of them. Like, ooh, that was not a very good drawing. There we go. Here's some users, right? And then I can send these all back up to the core, and then maybe the core, in essence, is filled with multiple switches, right? Or, I'm sorry, the distribution layer. I keep saying core, and I've got to stop doing that. The distribution layer. And then maybe then, too, I'm going to take all of these, and I'm going to aggregate them up into some big, powerful core devices, right? Okay. So what I did is I basically just took one part of this for the purpose of our configuration to say, okay, we've got a few users. Generally, you're going to do routing at the core. Or I'm sorry, geez. Again, generally you're going to do routing at the distribution layer. Now let me make sure that I write distribution routing here, now that I keep calling everything core. So you're going to do your routing at the distribution. So that's why I'm going to do it here. I'm going to configure my SVIs in this instance here. In the next instance, I'll do a routed port. What's going to happen is these here will be trunks, and they're going to carry all of my VLAN traffic. I'm going to combine these also into ether channels. You do not have to combine them into ether channels for this to work. It just stands to logical reason for me. If I'm taking a bunch of, say, 100 meg connections from down here and I'm aggregating those users, that I'm going to want to make this a larger link, say an 800 meg link or whatever, or maybe I've got, here I only have fast Ethernet, but maybe I've got gigabit and I want to make that one link. I want to aggregate that one link into one larger bandwidth link, because remember, if I leave both these links here and I don't ether channel them, then one of them is going to end up blocking for spanning tree. So let me erase my big mess here. Okay, so we're going to go ahead and configure this. We're going to pretend like, or we're going to simulate, maybe pretend is not the word. Whoop, sorry, hold on. So we'll simulate that this switch here is my distribution, and this switch represents my access layer, and I'm going to aggregate my user traffic up into my distribution, where I'm going to do my routing. And in this case, I'm going to do my routing via switch virtual interfaces. So let's go ahead and configure that. All right, so the first thing I'm going to do again is I'm going to go ahead and configure my layer 2 switch so that my PCs are in the proper VLANs. So if I do, whoop, 0/1, and that's going to be in VLAN 10. Switch port access. I just used tab completion on the earlier one. VLAN 10. It says here, now here's just another way, so I'm just demonstrating. It says it doesn't exist, so it's going to go ahead and create it. And we'll do a no shut just to make sure. Int FA0/12. Switch port access VLAN 20. I did shorten it up, but I'm just about going to guarantee you that the device will know there should be another S there. So I go ahead and hit enter, and it again creates VLAN 20. So let's just double check that 10 and 20 are there. Show VLAN brief, and 10 or 20 are there. So actually right now we're doing pretty good. Now let's go ahead, we want to send both, we want to use 5 and 6 as trunks, so we want to be able to send both VLANs across. And also remember, we're going to ether channel it. So basically it's going to be one higher bandwidth trunk. So let's go through and do config T. Remember, I don't have to do this for inter VLAN routing to work. I do have to configure the trunks, right? Because I have to be able to get the VLANs across the link to the SVIs or to the multi-layer switch, either way. But I don't have to configure the ether channel portion. I'm just choosing to do so. Int range FA0/5 to 6. Switch port, and here I'm going to do this. I'm going to make this quote-unquote mistake just so you can see what the output will look like. But in this particular switch, I can do, no, not this one. It's the other switch, sorry. So we'll do switch port mode trunk. My other switch, I can do .1Q and ISL, so I've got to configure the other thing first. So when I go over there, I'll go ahead and demonstrate that. Switch port mode trunk, good. Okay, then I've got to create the channel group. I'm going to create channel group 1. Channel group 1 mode on. That will put them in the same ether channel or channel group or port channel, what do you want to call it. Okay. Now I'm going to go over to my multi-layer switch and configure that. So what are one of the rules? One of the rules is the VLANs have to be on the switch. I could have done VTP maybe and configured them here, and then that would have meant both switches. So if I do a do show VLAN brief, I'm going to see my 10 and 20 aren't on there. So I'm going to create VLANs 10 and 20 because I don't have an interface that's actually going to be in VLANs 10 and 20. So we do VLAN 10, 20. And then we go ahead and exit out. So now if I do a show VLAN brief, it should be in there. Yay! And in fact, 10 and 20 are in there now. So we're good there. We meet that criteria. Now we're going to make ports 5 and 6 trunking ports, and we're going to bind them into a port channel or an ether channel. Int range FA0/5 to 6. And here's where I'm going to show you the error or the reminder that you're going to get if I can do both .1Q and ISL on the switch. It's going to tell us then that I can't be configured in trunk mode until I decide basically whether it's going to be .1Q or ISL. So I'm going to do switch port, trunk, encapsulation, .1Q. Now I can go ahead, let's hit the up arrow. Now I can go ahead and do switch port mode trunk without any problem. And then I'm going to add it to channel group 1 or port channel 1, what do you want to call it? Channel group 1 mode on. Okay. Now let's verify that our ether channels are working by doing a show ether channel summary. Oh, they're not. So I must have missed something there. Hold on. All right. So my ether channels are on. I'm pretty sure I configured it correctly. Another command you can do to troubleshoot this a little bit is show CDP neighbors. It'll show us the layer 2 information, so we don't have to worry about anything above layer 2. What it does is if I don't see any neighbors, then I know something has gone wrong at layer 2 or layer 1. I already have a suspicion of what I've done wrong, but I want to show you anyway. So show CDP neighbors, and I don't see any neighbors, but I should see my layer 2 switch. My suspicion is what I didn't do was do a no shutdown on the interfaces, and usually by default, and the reason why I didn't is usually by default the switches, the interface, it's the physical interface itself is already in a no shutdown state, but I had shut them down earlier because I've got a lot of interconnections. If I were to show you how my lab is actually interconnected, I didn't want those to interfere with what we were doing in the previous demonstration. So anyway, if I do a config T and I do an int range FA0/5 to 6 and I do a no shutdown, and wait a second, I bet you our ether channels will come up. Wait for it. All right, our interfaces have come up, and it also does show port channel 1 is up, so let's make sure that that's true since I tried to show you that earlier. Ether channel summary, and now we're running. We're good. Our layer 2 ether channel is doing well. Both of our ports are bundled. They're in use, and then the S tells me that it's a layer 2. So we're doing well now. So now we've got our connection between our between our multi-layer switch and our layer 2 switch. Now we've got to go ahead and configure our SVIs. Interface VLAN 10. That's my first SVI. Give it an IP address. I should have gotten rid of scrolling for you guys. Give it an IP address. 192.168.10.1. There, my router's gone now. It's not even part of this, so we'll be able to use this just fine. 255.255.255.0. Okay, then do a no shut. Remember, because that was one of the rules, we had to activate it. So we have to create the VLAN interface, make sure the VLANs are in the VLAN database, we have to give it an IP address, and we have to make sure it's administratively up. So then we go into interface VLAN, VLAN 20. And again, it tells us it's up. Give it an IP address. I had to learn to move my cursor or my pointer out of the way for you guys. And then we bring it administratively up. Okay? All right, so let's do show, run, and just look at the main parts that we need to be interested in here. So we've got port, it's 5 and 6. These are all default and they're shut down because we're not using them right now. I purposely shut them down. So if we go up to 5 and 6, they are trunking. I didn't configure my native VLAN. At this point, it by default, if you don't configure native VLAN, will be VLAN 1. That's, I'm going to leave that. That's fine. I know I said in the picture that I was going to do native VLAN 50, but this is fine. We'll just use it as VLAN 1. We'll leave that as the native VLAN. So let's see. We do a show. Let's exit back so we don't keep using the do command. Show whoops, no, I just made it mad. Show interfaces trunk. Okay. See, it's a port channel. It's on the encapsulation.1 queue. And again, like I referred to earlier, if I don't set the native VLAN, which I decided not to do, it would be VLAN 1 by default, and so it is. Let's do one more thing. We forgot something in this configuration. I'm going to show you how you can tell that you forgot it. Let's look at our routing table. If we do a show IP route and we forgot to enter the global command IP routing to tell this switch that it can go ahead and do IP routing, this is what you're going to see, okay, when you do the show IP route command. So this indicates to me that I forgot to globally enable IP routing. Let's go ahead and config T and globally enable IP routing. Now we should be doing pretty good. So now if I do a show IP route, I should see a normal routing table, and I do. These are my directly connected interfaces. I now see what looks to be a normal routing table. We should be ready to go now at this point. We should be able to test that, in fact, our SVIs will route from PC1 on VLAN 10 to PC20 in VLAN 20. All right, so I'm going to go ahead and bring PC1 over, bring its command prompt over. Let's see, we just need this part. And do an IP config again. You can verify that my IP address is in a different subnet than what I'm about to ping. .20.10, and we're successful. So in fact, our SVIs are, so our packet's going across our ether channel, our trunking ether channel, to the switch virtual interfaces, and then the multi-layer switch is routing it back out to VLAN 20. We're going to do one more thing. Get this out of our way for a second. And we're going to pull back our MLS configuration. There's a little command you can do. Remember what our rules were. We had to have VLANs. The VLANs had to be in the VLAN database. The VLAN interface had to be up. And we had to have a layer 2 interface, access or trunking, that was active, right, for that VLAN? Or that was active, I should say. So one of the things that happens is by default, when my layer 2 interfaces go up or down, that can change the state of my SVI. So if I have interfaces that we're counting as my active layer 2 interfaces and they go down, my SVI can go down. So if I don't want that to happen, I can issue the command auto state exclude to say, hey, exclude this interface from deciding whether or not my SVI goes up or down. So I go config T, int range FA0/5 to 6, and then I'm going to go ahead and do switch port, auto state exclude. Oh, it didn't like that. Hold on. So we tested it. Everything works fine. We did well there. One other thing that you could do is, let's say that you don't want, some of the rules that we had were, we had to have, the VLANs had to be in the VLAN database or had to be on the switch. The VLAN interface had to be up, and we needed to, or I shouldn't say had to be up, it had to be administratively up, and we needed to have a layer 2 interface active. If there's an instance where you wouldn't want an interface to a particular interface to help you decide whether or not the SVI is up. Because remember, if that layer 2 interface that's supposed to be your active interface goes down, my SVI is also going to go down. If it goes up, my SVI will also go up. So if for some reason you don't want a particular interface to be a part of that decision, you can issue the command switch port auto state exclude to tell that interface that, hey, I don't want you to be part of that calculation or that decision process. Hold on. So if we just go on the interface itself, switch port, auto state exclude. Oh, LUDE. I'm going to get better with writing there. Auto state, switch port auto state exclude on the interface, then it won't participate in deciding whether or not the SVI is up or down. All right, so we're going to go one step further now, and we're going to configure a routed port. I'm going to go ahead and we'll first look at some of the rules of a routed port. A routed port is simply this. It's a physical interface on the switch that does routing, same as a router. It's just a physical interface. I'm not configuring software. I'm just telling that interface that it'll be a multi-layer or a layer 3 interface, and it can do routing. So it's a physical interface on the switch. I'm going to take a layer 2 interface and make it a layer 3 interface by issuing the command no switch port on the interface itself. Then I'm going to configure an IP address on it. So once I issue the no switch port command, it's just like a router interface, except for one thing. Well, I'm sure there's other things. This is the one thing I want to make sure I don't forget to tell you. The first thing is enter the no switch port command, right? Then configure an IP address and a subnet mask on it, just like you would if you were configuring a router. Then you issue the no shutdown command to physically bring the interface up, right? And then if you want to route, in this case, we're actually going to route to another router. So I've connected in my next interface, basically, or my next topology, I've basically taken the previous topology and I've just added a router to it. And we're going to configure a routed port. So now if I want to route, let's say, from my PC1 all the way up through my multi-layer switch through to my router that I've connected, I've also then got to configure a routing protocol. So if I want to route with another multi-layer switch, if I want to connect 2 multi-layer switches or multiple of them, and I want to route between them, or I want to route to another router, I've got to configure a routing protocol. One caveat is that routed ports, so when I configure this being a routed port, it's going to work, just like a router. The only caveat is I can't do sub-interfaces. So remember when we did router on a stick earlier with the router itself, when I configure the port on this switch to be a routed port, it won't be able to do the sub-interfaces. So we won't be able to do like multi-layer router on a stick or whatever. That it's not able to do that. So let's go ahead and we're going to add our additional router to the topology. So here's what my new topology is going to look like. Same thing as we had before, so I've still got all of this, right? And in fact, I'm going to leave that configuration alone because it's fine. We know that it works. All I'm going to do is I'm going to add this part, right? I'm just going to go ahead and add the, I'm going to go ahead and add my router here. I'm going to do one other thing, because a lot of times if you're going to connect say this is your distribution or your core, and you want to go out to the internet. A lot of times, if you're going to do that, you'll connect it to this router, and then the router. So anyway, a good use for this routed port is to connect to a router that goes out to the internet. So I want to, in a sense, simulate that. So I connected my router, and then I'm going to configure a loopback, which is why I call it LO0. He's going to represent my service provider or some IP address out on the internet. Okay. So the purpose here, we're just going to create a routed port. Okay. I should probably erase it. I'm getting to have a lot of ink here, as they say. But I'm going to configure this link as a routed link. It means this port's going to be a routed port. This one already is. It's a router, right? And then I'm going to configure a loopback interface that's going to simulate, a network out or an IP address out in the internet. So my routed network then, or this link, is going to use 1.0 IP address. This here will do a 2 network. Okay, so we're going to go ahead and leave it this part the way it was. We're going to just add a router. We're going to add a loopback, and we should be able to go from both of our PCs up through to this loopback or our simulated internet. All right, so I brought my router in. I'm going to configure the router first. So go config, whoops. Now the interface was my gigabit 00 on the router. Give it an IP address, 192.168.1.2. I'm going to make 1.1 the interface on my multi-layer switch. And do a no shut. And then I'm going to create my loopback interface, which is just my virtual interface that I'm using to sort of simulate the ISP or an internet router, or an internet network, sorry. IP address 192.168.2.1 is that subnet. Now remember earlier, even though I'm working on the router earlier, we were talking about multi-layer switch. It's true because basically what's going to happen is I have a router connected to a router that has a bunch of interfaces on it. I mean, that's basically how my multi-layer switch is going to act once I've configured it. 2 routers connected to each other. Remember, whenever we do that, we want to go through a router. We want to be routed through. We have to have a routing protocol. I'm just going to use EIGRP because it's easy. Okay, router, no special reason why. It's not like my multi-layer switch has to use it. In Autonomous System 1, network. So the networks on this router are 192.168.1.0. And the network, the other one is 192.168.2.0. Okay. And issue the show IP route command. I see my 2 directly connected. So now let's go ahead and go to our multi-layer switch. He's already in global configuration. Remember, we're going to leave his other configuration alone. We're just going to change Fast Ethernet 3 to be a routed port. So interface FA0/3. No switch port first, right? No switch port. Now it's a layer 3 switch, or layer 3 port on my switch. So now it acts just like 2 directly connected routers. Give it an IP address. Remember, because now they're directly connected, I am directly connecting this multi-layer switch to R1. They're behaving now at this point like 2 directly connected routers. So they've got to be on the same subnet, 192.168.1.1. Let me issue the no shutdown command. Let me get that out of your way. Let's do our ping command. And it was successful. It just took a little second to kick in, but we're good to go. You can always ping directly connected, right? So if you're directly connected, assume it. You don't need a routing protocol. That's what I should say. You don't need a routing protocol to ping directly connected. There'll be a lot of other factors that I could mess up along the way, but we don't need a routing protocol to do it. So as an example, if I go ahead and I ping 2.1, it's not going to work. Why? Because I have to go through the router to get to it, right? For my multi-layer switch, to get to my simulated ISP, I have to go through the router. So I need a routing protocol, which I've already configured on the router. Let's just go ahead and do it here. Router, EIGRP, got to be in the same autonomous system, right? If I want them in the same group. Networks on here are 192.168.10.0, 20.0, and 1.0, right? Those are my 3 networks that are being serviced by my multi-layer switch. So if we exit out, and you can see too that my adjacencies have come up. EIGRP is happy right now. Whoops. What if we just hit end? If I do a show IP route, show IP route, look at that. I see all my directly connected routes, which are my 10, 20, and 1, the ones I just advertised, but now I also see an EIGRP route to that loopback. So now I should be able to ping that loopback. And we can, very successfully. So now you have configured up to this point, you've configured route on a stick, you've configured switch virtual interfaces, and now we've configured a routed port. That was everything I wanted to look over and cover. We'll just do one more thing. We'll move over to R1, and we will do a show IP route. Look at that, to see that all of our SVI routed interfaces have propagated to my router. So now we've configured them correctly. We'll move this out of the way, close it up, we're done.